Today we're going to be talking about solving logarithmic equations using the one-to-one property. So last week when we were talking about exponential equations, there was also a one-to-one property that basically said if you had some base, I'll use 4. So if I had 4 raised to the exponent of x, and on the other side of the equation I had 4 raised to the third exponent, we were basically asking, well, if this base is 4 and this base is 4, what would the exponent have to be in order for this to be a true statement? And we know that in order for this to be true, our x value would have to be 3, since 4 to the third has to be equal to 4 to the third. Well, there's a property that also goes along with logarithmic equations that's pretty similar to that idea. And this is called the one-to-one property. And that's basically saying that if we have some log base on either side of the equation and the log base number is exactly the same, the stuff that's next to that log base here and here has to be equal. And it's the same thing for the natural log as well. So if I have a natural log on one side, a natural log on the other side, the stuff next to the natural log would have to be equal. So what does that look like? Well, our example 1 is asking us to solve log base 3 of x equal to log base 3 of 7. So I'm noticing that my bases are exactly the same on either side of the equation. So the stuff that's coming next to the log base 3 has to be equal. That's what our one-to-one property says. So the stuff right here, the x, has to be equal to the stuff right here, 7. So x must be equal to 7. And with these equations, you always want to make sure that you are checking your solutions, because there are going to be instances that the solution might not actually work. So I'm going to take my original equation, log base 3 of x equal to log base 3 of 7, and I'm just going to plug in what I got for the x value here just to check to make sure it works. So log base 3, I'll plug in my x of 7 equal to log base 3 of 7. That works. And what we're really looking for here is to make sure that this number on the inside of the parentheses is positive, because we know that we can't take a log of a negative number. So that's really what we're looking for when we're checking. So that means that my x value here of 7 works. That's a solution. All right, let's look at a second equation. So let's solve log base 3 of 2x minus 1 equal to log base 3 of x plus 5. So this one just happens to be a log base 3 on either side as well. It doesn't have to be 3. The base could be something different. It could be 7, it could be 10, it could be 15. But as long as this number matches this number, then that's just basically telling us that this stuff has to be equal to this stuff. So let's go ahead and set that up. So 2x minus 1 must be equal to x plus 5. And I'll go ahead and solve this like I would a normal linear equation. So I'll subtract an x. That will give me x minus 1 equal to positive 5. And then I'll go ahead and add 1 to both sides. So that's going to get me an x value of 6. So again, I want to make sure that this is going to actually work as a solution. So I'll show my check here. My original equation is log base 3 of 2x minus 1 equal to log base 3 of x plus 5. And I'll go ahead and substitute in my x value of 6 up into this equation. So log base 3 of 2 times 6 minus 1 equal to log base 3 of 6 plus 5. I'll simplify this just to make sure it works. So 2 times 6 is 12 minus 1 is 11. And on the other side, 6 plus 5 is 11. So this works. These values are positive. That checks out. So that means that our x value of 6 does work. All right, let's look at one more example. So this one's involving now natural logs, and we've got some quadratics happening. So the one-to-one property again works as long as we have an ln on this side and an ln on this side. The one-to-one property is basically telling us that this stuff must have to be equal to this stuff. So I'll set that up. X squared minus x minus 2 equal to 6x minus 8. And I'm noticing that I have a quadratic forming on this side of the equal sign. My x squared is positive over here, so I'm going to leave this x squared where it is, and I'm going to bring this other stuff over to that side. So I'll do this in one step. Subtract 6x, add 8, because I always want to get one side equal to 0 in a quadratic equation. So when I combine like terms, that's going to give me x squared minus 7x and then plus 6 equal to 0. And then I want to go ahead and factor this. So I'm looking for factors of positive 6 that add to negative 7. That's going to tell me that my factors are going to be x minus 1 and x minus 6. Since negative 1 plus negative 6 gives me negative 7, and negative 1 times negative 6 gives me a positive 6. And then I can use my zero product property to solve here. So break this up, x minus 1 is equal to 0, x minus 6 is equal to 0. So that's going to tell me that my possible solutions here are either positive 1 or positive 6. But again, I want to make sure that I'm checking these to see if they both work. And I'm going to use my original equation again. So ln of x squared minus x minus 2 equal to ln of 6x minus 8. I'm going to check my x equal to 1 first. So I'll go ahead and substitute in 1 for any x value that I have here. So 1 squared minus 1 minus 2 equal to ln of 6 times 1 minus 8. So when I simplify this, 1 minus 1 is 0, minus 2 gives me a negative 2. And 6 times 1 is 6, minus 8 is negative 2. So here's an instance where we do get the same thing on both sides of the equal sign, but the problem here is that we have a negative number on the inside. So this actually doesn't work. If you tried to take your calculator and evaluate the natural log of negative 2, you're going to get a non-real answer. So anytime you end up with a negative next to your natural log or your log, that's going to mean that that's not going to be a solution. So x equals 1 is not a solution, but let's check x equals 6. So ln of 6 squared minus 6 minus 2 equal to ln of 6 times 6 minus 8. That's going to give me 36 minus 8. And same thing over here, 36 minus 8. And I know that 36 minus 8 is definitely a positive number. So this is actually going to end up working as a solution. I don't really care what these values are. Again, I'm just checking to make sure that they're going to be positive. 36 minus 8 is definitely a positive number. So we've come to the conclusion that x equals 1 is not a solution, but x equals 6 is a solution. So make sure that you are going back and checking your answers on these. If you have any questions, please let us know.